Alright, hello, this is Ritchie, and this is my CE 383 Hydrology and Urban Water Systems project. So with this video on Google Earth, I wanted to take it all the way from space and zoom all the way into my family's farm out in Mount Pleasant, zoom in on Black Run Creek, kind of get a cool view of where it is out on the earth. So these next two pictures are a picture of downstream of where I analyzed the creek and upstream. I just kind of wanted to give a little sense of what the creek actually looks like. So some background information of the creek that runs through my family farm. It's called Black Run Creek, and it's found mostly in Mount Pleasant, North Carolina. My family's probably had it in our family for over 100 years, and we've mined for gold there for the past 60 years or more. Attached is a GIS picture kind of outlaying the boundaries of the farm. It's about 240 acres, and we've got a lot of land, a whole lot of forests, and some good pastures out there. So to go a little bit more in depth on the cross section of the portion of the creek that I decided to analyze, the area came out to be 11.81 square feet. The wetted perimeter ended up being 17.35 feet, and the top width of the creek was right at 17 feet. As you can see from the cross section on the page, you can see that the bottom of the channel kind of undulates a little bit, but it was pretty similar on both sides. You can see that it gets deeper as it gets more centralized, and the left and right side of the creek channel they were almost vertical, so that's why they're drawn fairly vertical on that. So then to get a little bit more in depth, I have attached the Manning's equation. Since we're in US units, it's 1.486 over Manning's roughness coefficient N, which I found to be 0.04 from the tables. The area again is 11.81 square feet. The hydraulic radius came out to be 0.68. And then for the slope, I used a couple applications on my phone and also my eyes to try to figure out how much vertical depth it dropped over 500 feet, because I went 250 feet upstream and downstream, and it came out to be about 2 feet of drop. So then doing Manning's equation, it came out that flow was 21.45 cubic feet per second, which then Q is equal to VA, so V is equal to Q over A, and so velocity is 1.82 feet per second. And when I filmed it, just to estimate the velocity, I kind of saw that it was about 2 feet per second, so that's fairly accurate, I would say. Here's a couple more images of the creek that I analyzed. The first image is getting the top width of the creek, and then the second image is me getting the depth of the creek. So this next slide covers the watershed delineation as well as time of concentration. So the right image is the watershed delineation, and at first I didn't really think that the watershed was going to be this large. My family's farm is roughly 240 acres. I was thinking, alright, it's going to be 500, maybe 600 acres. Well, it came out to be 3,296 acres. I didn't really realize that Black Run Creek was as large of a creek as it is, and I didn't know that it actually went all the way to where Rowan and Cabarrus County line meets. And then it also has quite a few stray little creeks that run into Black Run Creek, and so those are absorbed in that watershed. You can see that there are quite a few streets, but as I drove while I drive around that area, I can see that water does indeed flow over those roads. So that's why they're included, but there are some roads that act as boundaries, and then there's quite a few other creeks that kind of create a boundary or are on the other side of ridges that kind of make those boundaries between those two creeks. And time of concentration, there's that purple arrowed line. And so the time of concentration is the time needed for water to flow from the most remote and furthest hydrologic point in the watershed to the outlet point. We used Kirpich's method and then the NRCS method. And the Kirpich's method came out to be, time of concentration came out to be 131 minutes, while the NRCS method came out to be around 200 minutes, which is 3.3 hours. The NRCS method is a little bit more in depth. It allows for sheet flow, shallow channel flow, and then of course open channel flow. And so that time of concentration is the one that I used. Now we're getting into the meat of the substance of this project, and we're trying to calculate the peak flow. We use the rational method and the NRCS TR55 method, both of which use coefficients. The rational method uses C, and the TR55 uses CN, which is curve number. Both are just kind of analyzing the ground cover and the percentage of grass or the slope, and forests versus grazing and all that. And so I calculated, came out to be for the 10-year rational, it was 2,033 cubic feet per second, while the TR55 was 1,677 cubic feet per second. The rational method for 25-year was 2,618 cubic feet per second, while the TR55 method was 2,282 cubic feet per second. And those numbers vary because the rational method is, for North Carolina, it's supposed to only be used for 10 acres. And my watershed comes out to be, what is that, 300 and something times larger than 10 acres. So the NRCS TR55 method allows for medium to large sized watersheds to be analyzed for peak flow, and so I would say that the TR55 method is more accurate and a little bit more precise. So in conclusion, I tried to take myself to a 30,000 foot view of the watershed. This allowed me to get a solid base of hydrology, but then by zooming into that 17-foot wide creek, Black Run Creek bed, and analyzing it the many ways we did, it allowed me to get a better grasp of some of the important topics discussed in this course. And it was a broad learning objective, but I found it that much more meaningful, and I thoroughly enjoyed this project.